expect a summary video. We're here on 57th, East 57th in New York City. And what we have here is a fire escape on the facade of this building that has some issues. The code requires that we examine, test, or certify this fire escape. At this time, we cannot certify or test this fire escape. She does have structural issues that I'm going to be discussing, and because of that, we cannot test or certify this fire escape at this time. I will be making recommendation as to what needs to be done, what is the main reason, what's the main cause, but the code requires that all fire escapes be structurally sound and be kept painted. So let's deal with the paint issue first. The first thing about this paint, it's older than 1978, presumed to have lead, so anybody scraping this fire escape, you got to collect the chips. So that under the EPA guidelines, once the scaffolding that looks like this comes, we got to put out the plastic. The men got to wear their protective suits as per the EPA guidelines, collect all the chips, bag them, and then dispose of them properly, and then structural work can commence on this fire escape. So that's step one, is meeting the requirement. Step two is must be structurally sound. Well, the fire escape has got nothing but original hardware. All these bolts that are square heads, these are all original hardware. These should have been swapped out in the 25th to 50th birthday of this fire escape system, which it was never done. So I walked the entire structure, and I am finding no connections that have been swapped out in any way. So you're looking at a fire escape that, even though some connections may be still good, what we have to do is we're going to have to load test, or we can provide you with an opinion letter stating that I see no rust in this connection, but the bolt is 50 to 75 plus years old, and should anything happen, there's going to be a disclaimer letter that says if these fail, the responsibility is back to the ownership of the building. Otherwise, we change these fasteners out completely, there is no load test. Otherwise, we can spot repair only the bad connections and then load test this entire structure of this fire escape. So that will get you no liability letter if we can load test it, but it's not usually very feasible. All right, so let's talk about, so we recommend highly that all the fasteners be done. There's a lot of work to be done here. Besides just fastener swap out, every connection must be sealed with silicone. So you repair it, you spot prime it, you seal it with 50-year silicone, and then you're going to give it a full paint job. That's going to buy a lot of time for this building, at least 50 years. But you do have a lot of steel that's rotted out. So this rotting out of steel is happened for a reason, and that is just poor design. So the fire escape does have some issues here, and so a lot of these are going to have to be new gussets underneath. So a lot of it will answer some of the questions, and a lot of the siliconing. We have some issues where the steel has rotted out. So a lot of this steel, they'll have to reinforce it once they've cleansed it, but we have steel missing. This is what happens when you leave it unchecked for many years. So that's happening here. So a lot of this will have to be reinforced. You don't necessarily have to remove the railings here. They can be repaired in position, no welding, because the EPA does not allow you to weld. So a lot of this is going to have to be fasteners. Basically, if you're sistering the top, sistering the mid rail, or sistering the bottom rail, it can all be done with fasteners, and that's the repair recommendation that will be designed for this system here. Okay, this does extend to the other side here, so this is all part of the same building. This is already scaffolded by another building, so that's good. But again, same problems. A lot of your corners have to be, create a gusset or a system to basically tie these back in, so that there's not a major activity going on in these corners other than reinforcing these corners. Tie backs into the building, get a silicone shut these things, scrape and paint from below and from above, and then you have the steel. See, it's rotted right out of the building. See right there? You can even see it, so that support is not. And that's primarily on this extension here. Looks like there's never been any cement work done on these. Those over there, everything seems to be good, but unless I'm wrong and I'm in the wrong building, this looks like it's the same building. Yes, so these are all rotted out of the building, so these are not safe right now as we speak, and pretty bad. So we do have some emergencies here. We have some emergencies on the front stair there, and that'll be talked about. So the ladder system, it's a lift. You lift the ladder and then it drops to the ground, hits the ground, and stays down. But again, all original hardware on the ladder system. Some of the tiebacks are broken, but this is not the biggest issue on that. Again, the cement spalling there. There's some cement spalling here. So these connections all here seem to be spalled right out of the building, and they've eaten some of the steel. These look like they haven't had attention. A lot of it is right over this canopy, so that's another problem. Your treads are a concern all the way up. About 25% of each staircase, the treads have huge amount of rust growing in them, making them all suspect, okay? So as you can see, and you start going up, these are all riveted. So this fire escape is probably 75 years or older, because rivets tend to be older fire escape systems. Some of these have these doubles and they're welded. Welds have to be x-rayed or load tested, but as soon as we pop in some bolts there, we're going to eliminate, silicone shut that thing, and we don't want to x-ray or load test these welds. We want to pop. The corners are all rotted. These corners all have a rivet in the corner. It's probably too dark here, but let me see if it'll go in there. Every single corner on this whole structure has got issues all the way up. So, and this is also rotting against the building here too. So this first floor, you got all of them need cement work, and or the steel is actually rotted halfway into the building. So those need to be addressed immediately, sistered. Looking up from this side, you got a standard paint job on the whole structure. And then again, every corner, see that rotted corner right there? That's happening in all the corners of this fire escape, all the way up to the very top. Okay, now let's just talk about the fire escape system in the stairs. I'll do that on a separate video right now, but a lot of these stringers, you're gonna find that the bolts at the top are rotted out. There's one of these staircases at the left side stringer, there's no more bolt there, and it's actually another life safety issue. But about 25% of the treads are showing evidence of rust all the way up to the top floor. We got, again, all original hardware that is starting to lose the nuts, all original hardware. So no maintenance on this fire escape of any kind. So primarily down at the ground floor is going to be the cement and possibly having to change the supports back into the building, or at least sister them with another one with probably an epoxy bolt, so you don't have to go back into the same cavity. We'll see what the final is going to be once we do a little bit more investigation. Any questions? Fire escape engineers, inspect the summary video. This is inspection part 1, 866-649-0333, 866-649-0333.